There we are. All right. Welcome everyone to the Hawaii Aquaculture Tech and Research Brown Bag, sponsored by NELHA and the Hawaii Aquaculture Collaborative, which is facilitated by the University of Hawaii Sea Grant College program. So I'm Jean Schneider on the facilitation team with Kai Fox, Cherie Kawahi, and Keith Olson. And I just want to make sure that everyone can see the screen. Give me a thumbs up. Are we good? Okay, great. Thank you. The recording of today's sessions and slides will be posted on our website, hiaquacollab.org. Please introduce yourselves in the chat, use the hand-raising feature or the chat to ask questions, and make comments during our discussion. This is the Technology and Research Working Group of the Hawaii Aquaculture Collaborative. The purpose of this working group is to provide a space for Hawaii aquaculture industry leaders and stakeholders to collaborate on technology and research solutions. Our format is about 10 minutes of background context and a problem that an industry leader is trying to solve. And the rest of the time will be for questions, discussions, and possible solutions. We are piloting this format and we'll be making adjustments in future sessions. Going forward, we'll meet every second Wednesday of each month at noon. Over the next few months, we will be focusing on projects working to produce local feed. We know that feed and shipping of feed is one of the highest cost inputs to aquaculture, and we know of a few projects working to figure out how to produce feed using local inputs. So we'd like to get them all at the table to see if there might be opportunities to leverage resources and collaborate. So on August 10th, we'll hear from Neil Sims at Ocean Era on his current project. If you have an aquaculture tech and research problem you'd like to solve, please contact Kai. And for more info, please see our website. In other collaborative news, we're planning a summer meeting of the Workforce Development Group to continue our discussion on workforce demand and career pathways into aquaculture. We're getting guidance from our steering committee and are excited to have some interest from legislative partners, a few who are on the call today. Mahalo for attending. And please check out our collaboration with the Hawaii Ag Foundation on the Aqua Plus Culture video that aired on KHON last month, is currently airing on Hawaiian Airlines in-flight programming and can be streamed on YouTube. We will post that link to the video in the chat. And now, without further ado, let's get to our business at hand. We'd like to welcome Dave Anderson from KauaiSea Farms. Mahalo, Dave, for helping us launch these sessions with such an intriguing topic. I'm turning it over to Kai to introduce Dave. Thanks, Kai.
Thanks, Jean. Welcome, everybody. I'm just gonna briefly introduce the Nomilu fish pond, which was completely closed off from water exchange for approximately 25 years following Hurricane Iniki in 1992, which killed all the native fish and created a nutrient-dense anoxic layer at the pond bottom. And restoration of the ocean algae is part of the KauaiSea Farms' efforts to return bivalve and fish production to the pond, has resulted in the return of many native fish and seasonally variable growth rates of the bivalves. Chlorophyll and salinity monitoring, as well as periodic nutrient testing, has revealed a unique dynamic environment presenting both challenges and opportunities for modern seafood production. And as Jean said, we're very fortunate to have Dave Anderson speaking with us today, who has been working in research and commercial aquaculture in Hawaii for the past 12 years and is currently the production manager for KauaiSea Farms. And KauaiSea Farms is a Hawaiian family-owned company that was created to bring economic security to Nomilu Fish Pond. And with that, I will turn it over to Dave. Thank you very much, Dave. Go ahead.
Thank you. Thank you very much, Kai and Jean, and thank you everyone for joining today. Kai gave a pretty great introduction there. So this is the Nomilu Fish Pond. It's a family-owned property. It's been in the same family for 3 generations, and KauaiSea Farm was started by members of that family to try to bring economic security and offset the costs of ownership. We are currently producing clams and ogo in contained methods, as well as fish through some more traditional extensive methods of natural recruitment into the pond. So just a brief history of the fish pond to help sort of frame the problem. The first real reports of anything at the area besides Hawaiian mythology and chants was in the 1850s, where there was a small Hawaiian fishing village there, reported by visitors. In the later 1800s, the property was leased and eventually sold to Walter McBride as part of a larger parcel for sugarcane production. The fish pond itself isn't really a good place for sugarcane production, obviously being a big saltwater body, so he didn't have that much interest in it. By 1900, we have the next report, and he is leasing it out to a Japanese fisherman, and there's not really much mention of what happened to the fishing village at this point. In the earlier 1900s, Philip Palama, who was Walter McBride's sort of right-hand man and main helper, was able to work out a deal to purchase the fish pond as just a single parcel outside of all the sugarcane land from Walter McBride, and it has been passed down for 3 generations in a land trust to his successors today. In the 1960s, the state of Hawaii introduced mercenary and mercenary clams to the pond, which is the same species that we're currently growing, and they absolutely flourished up until Hurricane Iniki in 1992, which closed off the Kauai channel to the ocean. So basically, the takeaway from this is that we had, from probably hundreds of years, constant maintenance of the channel, allowing water in and out of the pond and the water exchange, up until Hurricane Iniki, when everything was closed off. And then in around 2017, family members of the Palama family began restoring the pond, and Kauai Sea Farm was eventually formed. And we now have 2 ocean awais with lots of water exchange. So this is a good photo of the pond, so you can see sort of the color. You can see it's a pretty dark, it's normally a pretty dark green or brown color. It sort of varies between the two. The visibility is generally about 3 to 5 feet through the water column. The salinity in the pond is mostly around 35 ppt. Even in the biggest flood event that we've seen when I was working there for the past 3 years, the lowest salinity was 30 ppt, and that was right at the surface. So, you know, that's definitely going to be a biased sample, since all the fresh water is going to be going up to the top. We see a lot of variation in the growth rates of our bivalves in the pond seasonally, and sometimes even within a month. And we used to sort of attribute that to the changes in salinity. But realistically, a 35 to 33 ppt change in salinity really shouldn't justify the growth rate changes that we've seen. So the bottom of the pond is about 25 feet deep. From the period of 25 years where it was blocked off from any exchange with the ocean, it became a complete nutrient sink. So before the Kauai channels were reopened, the whole pond was pretty much dead with the exception of tilapia. Now we have about 50% tilapia and 50% native fish is the abundance in the pond. And there's quite a bit of native fish now. So you can see here, this is the the nutrient sink formed this hypersaline anoxic layer on the very bottom. In late 2021, we began continuously monitoring chlorophyll and salinity through a Pacquios meter that we were able to use. And we found out that the chlorophyll towards the top of the water column is actually super low, which was very surprising because we see so much color in the pond. So the question is, what are we looking at in the pond water if it's not chlorophyll producing microalgae? This stuff is more the chemistry of the pond. I'm sure there's a lot of different variants between everyone's background in chemistry. I'm not very, I don't have much of a chemistry background at all, and I've been learning this on the fly. But basically what it says is towards the top, the upper water column, the levels of chemistry is pretty similar to seawater. And then around 12 feet deep, there's a chemocline, which you can actually see when you dive down the pond. It's very visible. And then below that, it's just these extreme levels of all of the nutrients that have been tested in the water. And these values are all from a 2018 and 2019 master's thesis that sampled areas of the pond. And I apologize that everything's in micromoles per liter because I also don't really know how to read those as much as milligrams and micrograms per liter, but that is the values that we have to work with. The only value here that seemed off towards the upper water column in from what I've been able to research, was possibly the silicate, which is important for sort of our hypothesis of what we're seeing in the water and what's going on with our changing growth rates. So this is a graph of the data that we collected last year. You see the red line is the salinity and the green line is the chlorophyll. So the chlorophyll is going to be measuring the microalgae in the water, which is what we want. And you can see it's very low levels. And then we have two big events, one in December and one in January, where the salinity drops very fast. And those were two major rainfall events. During the first rainfall event in December, the salinity dropped super low and the chlorophyll spiked. And we don't collect this data on a real-time basis. We have to download it afterwards. So after this rainstorm, the whole pond turned clear. Like you could see 10 to 12 feet down the water column, the clearest that I'd seen it the whole time I'd been working down there. And the growth rates for December and January of our bivalves just skyrocketed. Like everything was growing unbelievably fast. And so there was a big surprise when we downloaded the data and we see that what we were looking at before, when the pond is dark, the chlorophyll and hence the microalgae levels are super low. And then when the pond turns completely clear, the chlorophyll and microalgae are spiking really high, and our growth rates are reflecting that. So it's sort of flipped over everything that we had been assuming when we were looking in the pond water. Now, the second rainfall event in January didn't elicit the same response in chlorophyll at all. You can see like these big spikes after this first event in December, and then from January, it sort of just wavers pretty similar, like pretty regular low, and the rainfall events were about the same amount of precipitation as gauged by the salinity change in the pond. The big difference between these two events was that the December event was a Kona low pressure system, which was accompanied with really strong southerly wind. And the second event was more of a trade wind storm. So it brings up the big question of basically, what are we seeing in the water when the water's dark, which we are now under the working assumption is that may be cyanobacteria rather than microalgae, which is not what we want for producing bivalves. And then the second question is, what is going on here where the chlorophyll spikes? Because that, if we could have those growth rates all the time, that would obviously be a perfect system for us. So we're thinking basically there's two theories of what's causing the chlorophyll to spike. Is it the rainfall is like putting runoff into the water that is adding nutrients? And so back to this, like you can see all these nutrients, these are just the nutrients that are measured at the bottom of the pond. But we can assume that like all of these micronutrients down there are in huge abundance. So the working theory is that basically like in the upper water column, the diatoms and the microalgae are nutrient limited by something, and that's allowing the cyanobacteria to flourish. Microalgae should be able to outcompete cyanobacteria from my understanding of water chemistry, but if it's limited by a nutrient, it won't be able to, and it'll allow the cyanobacteria to flourish, which won't produce chlorophyll and also won't be good for growing bivalves. So the question is, do we have rain events where it's flushing in nutrients and that is replacing the missing nutrient that's preventing the diatoms and the microalgae to flourish? Or are we seeing upwelling events where all of these nutrients from the bottom of the pond are coming up into the upper layer of the water column, and that's replacing the lacking nutrients, which is limiting the microalgae production? So we're kind of leaning more towards the upwelling theory, as when we had that big low pressure system in the December storm that caused this spike in chlorophyll, that south wind cuts opposite of the prevailing trade winds, sort of like upwelling events off the coast of California or the West Coast, whereas an equally large rainstorm in January without south wind didn't elicit any response. It's also possible that the first storm washed all the nutrients into the pond that had been sitting there without any rain event, but I still think that we probably would have seen some kind of a response in the chlorophyll if it was nutrient runoff rather than upwelling. So the big questions are, well, what are we seeing in the pond water? And are these chlorophyll spikes being caused by rainfall runoff, or is this upwelling of nutrient-rich water? So what I would love to hear thoughts about it, besides just the general ideas of this, are what are like direct and indirect methods for measuring algae and for measuring cyanobacteria. We are a not a super highly funded company, so we're looking for kind of low cost ways, even if they are indirect. Right now, we're sort of trying to measure microalgae based on dissolved oxygen overnight. You know, we'll see it drop if the algae's going up in the pond, but that's not really a perfect measurement. And I have no idea how to measure cyanobacteria in any way at all. And then the next question moves towards sort of like, if we go with, it is an upwelling event that's causing these spikes in chlorophyll and spikes in our growth rate, can we manipulate this and basically destratify the pond slowly over time in a way that will promote diatom and microalgae production? The silicate value is really important because we also have a solar powered hatchery that we use for our clam production, and sort of around the same time that our growth rate slowed, I started having a lot of trouble growing diatoms in our hatchery, and basically just tripled the amount of sodium metasilicate that was adding to the culture flasks, and all of a sudden there was no more problem for the diatom species of Chaetoceros. So that sort of kind of led me to think more about silicate, as silicate's a limiting nutrient for diatoms. Diatoms are what we want to be growing, and it seemed that just the very simple change of adding more metasilicate to our algae cultures fixed the problem we were seeing in our algae room. And so if anyone has any input on this, and also sort of like the most efficient methods for moving large volumes of water from deep towards the surface, we're kind of looking at differences between airlifts, Venturi pumps, or zero head pumps. Yeah, and so I'll stop talking and open up to discussion.
That's great. Thanks, Dave. I appreciate your insight on this. I think that probably the best way to handle questions or comments is if people could use the raise hand method on Zoom. Could start to get some questions in for Dave. Does anybody have any questions right now? Oh, Cherie.
Can you guys hear me? Cool. Dave, cool presentation. Can you go back to that slide showing when those spikes in nutrients occurred?
Sure thing. So yeah, so these are the spikes in chlorophyll, which is how we're measuring microalgae. And we're assuming that, it's an assumption. We didn't measure the nutrients that happen here. So it's an assumption that some kind of input of nutrients, either from runoff or from the rain, something from the rainfall or from upwelling in the pond, is what caused the spike in diatoms or microalgae that we're seeing as chlorophyll.
Do you know if, because during these times, if there was volcanic activity on Hawaii Island?
I don't believe so.
Not at all.
Yeah, I mean, I'll have to go back. I'm not sure.
Well, the only reason why I ask is because it was said that in chants, Hawaiian chants, that when there was volcanic activity on Hawaii Island specifically, they could smell sulfur out of Nomilu on Kauai.
Yeah,
and so I'm wondering if that heat or something may have caused an upwelling of something.
Yeah, I've heard those chants. I'm really not sure. I'm not an expert in that type of stuff. I've talked to geologists who said that wouldn't be that's just not really how the hotspot works underground, but I'm not going to say that I know about this stuff more than, I will say that I was down there when the volcano during the big lava flows a few years ago, and we didn't see any event like this with the pond turning clear.
Yeah.
But,
I
We weren't
was,
measuring chlorophyll then.
yeah. No, yeah, that's super cool. And just for reference, 2018 is when Kahialaka fully came out and took over Leilani Estates. And then since then, there's been periodic outpours. So if it just gives some kind of context.
Yeah, thank you. I'll go back through the news. I'm sure we can find that information.
Yeah, cool.
Thanks, Cherie. Looks like Jim, have a comment, question?
Yeah, thank you. Yeah, very interesting story, Dave. A couple things, you know, the graphic you have up there when you said, oh, gigantic salinities, that's not that much. 2 ppt is not that much,
No.
and most algae are not affected by that. So, and those are only a correlation between that salinity measurement and the chlorophyll. It doesn't mean it's causal. It doesn't mean, I prefer the idea that the wind was a factor and maybe started up a little bit. And if this was my project, I would figure out some kind of airlift system to put in there, you know, something like 4-inch pipe that goes not all the way to the bottom, but close to the bottom where that high nutrient layer is. And then you put aeration into that pipe at something like 4 or 6 feet below the surface, you know, where the air can still aerate. And you're lifting it and then put an elbow on the top so it's projecting it out across the top of the thing and see what happens, measure the chemistry and watch what happens. But I suspect, listening to your story, that it was a little bit of a turnover. You got some of those submerged nutrient layer up into the photic zone. You got algae growing, and then you got your bivalves loved it. And you want to try to manually replace that, you know, and have it be a continual upwelling of those high nutrients. I think that would be fantastic. That's my 2 cents on it.
Yeah, thank you, Jim. That is the direction that we're slowly moving towards. We're just trying to be very careful how we do it. But yeah, I agree. And I didn't mean to. This is these drop in salinity is a large drop for what we see, but you're right. And again, that was why when we used to see drops in salinity and we were thinking that was affecting our growth rates of the bivalves, same as with the algae, is like biologically 33.4 to 35.2 is a very small change in salinity.
Yeah.
Yeah, thank you.
Thanks,
Sure.
Jim. We have the next hand raise was from the NOAA conference room.
Hi, Dave. This is Alex Leonard from NOAA.
Alex,
I echo Jim Wyband's theory. I support Jim Wyband's idea about upwelling. And I'm thinking that maybe before you spend a bunch of money building airlifts, you might actually want to test out the hypothesis by sampling water at discrete layers and using it to culture your diatoms. And using discrete samples from taken at different depths, and see how you can use that to grow diatoms in the lab and just see if they respond better to waters from different depths.
that's a great idea. Yeah, that would be a cheap way to sort of test the theory. Thank you.
This cheap Niskin bottle could go a long way to answering your question.
We just ordered one.
Great.
Thank you. And then I think Neil Sims next, please.
Yeah, aloha kako. Great presentation, Dave. Great question. I think Jim's nailed it, and very, very good suggestion, Lex, to go and run some initial trials. I still wouldn't shy away from it, no matter what the results are from your small scale experiments. Don't shy away from putting an airlift in there. It's fairly inexpensive to do this at a small scale. It seems like you have electricity there on your barge already. Is that solar powered? Or
Yeah, it's all solar powered. But
yeah,
we have a barge with solar power, so yeah, it's not impossible by any means.
yes. So a little blower that would run off that. Shouldn't be too expensive. In terms of your big question about just being unclear about the cyanobacteria levels there, probably the best folk that we've worked with on marine microbiology, Craig Nelson from UH Manoa. I don't know if you know Craig. I'm happy to make an introduction to you. He's brilliant and easily excitable about questions like this, and good man to know. So I'm happy to make that introduction if you like.
That would be wonderful if you could. I would love to send him some. We could send him some water samples from different depth profiles and see what. I'd love to hear his opinion. Yeah,
he's got grad students that I'm sure would kill for a chance to get out there and pot around your pond for a day or two.
That's exactly what we need.
So I'll make that introduction by email follow-up.
Wonderful. Thank you, Neil.
You're welcome. Thank you.
Thanks, Neil. And looks like we have Fred up next.
Yeah, actually, my comments were going to be somewhat similar to Neil's comments in that you need to look at the water and see what you actually have in there. You seem to be speculating that you have cyanobacteria, but have you actually looked under a microscope to see what's there? I mean, I would think that the low chlorophyll measurements would indicate that you don't have cyanobacteria in large concentrations because they have chlorophyll too.
Yeah, this is not my, so I've looked at the water a lot under a microscope and have been very surprised at how little I see, but my experience is all from more practical microalgae production. So I'm looking for things in like, 5 to 20 microns size. I see some stuff in there that's much smaller than that. And I don't really know how to identify that, but I'm always surprised at how little there is that I've seen considering how dark the water appears.
Yeah, another thing that I don't see a measurement on is temperature, which is another factor that changes during storms and that could have some effect on the biology of the pond.
Yeah, that's very true. That's not something we've looked at very, very clearly. I'm not sure if it's even, it is being measured by our sensor, so I could definitely go back and look at that. Thank you.
Yeah, thanks. Thanks, Fred. Thank everybody. Looks like we don't have anybody else in the queue for questions. Does anybody have any other questions or comments for Dave right now? This is really fascinating discussion.
Well, thank you all very much. I really appreciate the opportunity and the feedback from some people who have probably my entire lifetime's experience more than I do. So it's very, very much appreciated.
Ame?
Hi, Dave. Really good presentation. I appreciated the numbers that you have. I was interested in your micromole measurements of nitrates. It looks like you have a big change as you move up from 10 to 20 foot depth up to 0 to 10 foot, 0 to 10 foot depth. Do you know in about what range you're finding the tilapia? I raise tilapia here in an aquaponic setup, and I often notice drops in my algae production when I've stressed my tilapia out by starving them of food pellets. I've been trying to acclimate them to a more naturalistic type of diet of insects and naturally occurring algae. And I often when they have a drop in mosquito or mite larva, gnats, or any other types of larval productions that they don't have access to, or snail production, the mollusca production, then they'll go for the algae. And they kind of clean all the surfaces of algae and they can filter. some species can just filter it out of the water. So I'm interested to know if you have a big like population of tilapia in the pond.
We do still have a big population of tilapia in the pond. The pond has become just going from like dead to alive. We have these huge population booms and busts of really small species. So there is a pretty large number of larvae of just changing species in the water all the time. But yeah, that's also something I had not considered. It is a huge body of water. I mean, it's an 18-acre pond, and there are a lot of tilapia, but it's not like, you know, they're kind of in clouds sporadically around the pond. It's not like you're walking on tilapia when you go and try to look at the water.
Yeah, that's
Okay.
interesting too. If you do know that you have tilapia, but like you said, you're not finding big clumps of them, like they're not schooling together in big collections. It could be that they're naturally predating on each other as they die off. And so, you know, there's a natural control at work, I think, in your population there. Do you know if you have Mozambicus or Niloticus? Do you know which?
It's the black gin. I'm not sure the scientific name.
Does it look like the ones you find out in the salt water along the seashore? The kind of silverish looking?
The
Yeah,
melanophedon.
they go from silver to a little darker depending on their color, and then they have the big black spots on their chin right below the mouth.
I forgot the name of that species that we find on our seashore. It does sound like you have more of that species than the Niloticus.
Yeah, I don't believe we have any. We might have a very small population of Niloticus, but yeah, it seems like it's all the black gin. They're all like quarter to half-pound fish. They don't really get any bigger.
Interesting. You might want to send some samples up to UH to see, you know, what they're consuming, what their gut collections are like.
Yeah, that's a great idea. Thank you, Ame.
Yeah.
Thanks, Ami. I think we have Vernon up next.
You're right. Hi, Dave. Good to see you. First thing I want to let you know is I got my microscope fixed. If you want to send samples, go ahead and send them to me.
I would love to.
The other thing is, do you know how much water exchange you're getting through your RY during big tide, you know, the big tides?
We're not measuring it, but it's got to be in the millions of gallons a day, especially during these big tides. Like right now with the king tides, like yesterday, you couldn't even like walk through the Kauai. You'd get like, it was like a rushing river. You'd get washed down. It was like up to my almost up to my waist and just like rushing into the pond.
Yeah, that sounds good. You know, at Waikolo, we're seeing when we get these king tides, we're seeing maybe about 20 or 30%, you know, water exchange in 24-hour tidal cycle. So I would think that would kind of stabilize at least your silicates if you're getting good exchange with your ocean, at least during those periods.
So what we're just not sure about is how much of that water is going through the pond. But basically that's what we've done to we've moved all of our production over towards where the Kauai are, and we're getting much better, consistent growth rates.
Right, good. And then the other question I had was, do you know what chlorophyll your monitoring system is measuring? If is it chlorophyll A or combination of A, B, and C?
I believe it's just A.
Okay. Yeah, that wouldn't distinguish the blue greens from the
right
other algae that are there. All right, thank you. I look forward to seeing your samples.
Yeah, I'll email you and follow up.
Great.
Thanks, Vernon. Looks like we have another question from Nelha Conference Room.
Hey, Dave, this is Keith Olson from Nelha. Just looking at the water quality and the concentrations you have there, they're very high, especially below the chemo line. That that's just huge, those concentrations. So basically
Yeah.
you have it in micromoles, but you just need to multiply by the molecular weight of the analyte, and that'll give you the micrograms or milligrams per liter. Even the nutrient concentrations in the upper levels, they're kind of high too in comparison to open ocean water. So I'd be cautious of mixing that, because I'd be concerned that because of the high concentrations below 12 feet, that could be quite significant. But I hear what you're saying in regards to there's a large mixing that's happening. And is that only happening at the higher levels? Like where does the water come in?
Yeah, the tidal makes the exchange.
The shape of the pond is where on the side where the OIs come in. So basically, like the pond, it's a should I mention it's an extinct volcanic caldera. So that's basically just like gone down towards the ocean low enough that it filled with seawater. The two OI channels that come in are on the southwest area of the pond, and that area of the pond towards about halfway to 2/3 back stays around this 10 to 12 foot depth. And then it's the back half of the pond where it just drops into where the actual like caldera once was. And so it drops pretty rapidly and then comes back up pretty rapidly on the far side of the pond where there's less exchange. So the theory is that the bottom of the pond's not really getting the benefit very much of the water exchange from the ocean.
Okay.
When would you say the silicate levels are high? 80 micromole per liter?
Yeah, there are 80 micromoles per liter. I don't know what the molecular weight of silicate, but I've seen, like if you were looking at ppb, that would be the number. So it would be a multiple of that. But I've seen them high in open ocean water too, but not a multiple of that. It would require to be more like, you're probably an order of magnitude higher
Gotcha.
for the upper levels.
60.
Wow.
Molecular weight is 60. So 80 times 60.
Yeah, so it may be even more than an order of magnitude. What I would normally see is something below 100 parts per billion.
Okay, thank you.
You got 40.
Trouble finding sort of a standard for that.
You got 4,800 in the surface area there.
Thanks, Keith. Looks like Vernon has another question.
There have been some studies where they've added iron to oceanic water and gotten some decent blooms up. So I'm wondering if maybe using chelated iron, ferric EDTA, might help, and that might explain how you're getting blooms after your runoff from the land. Maybe it's bringing down some solubilized iron, because from what I've read, the iron remains kind of hard to use unless it's chelated, and that's where, like in natural systems, tannins and other organic compounds help to chelate the iron and keep it available. So you might look at just trying to add some iron, and if it's corresponding to some of your freshwater runoffs. Anyway, just something else to look at. Make your life more complicated.
No, that's what, looking for every opinion possible before we start doing anything drastic.
Well, thank you, everyone. I'm noticing that we are over time. So, and that's a good sign that there was a rich discussion. Dave, do you feel like you got some good ideas, good takeaways?
Yes, no, thank you everyone for your time and your input. It's very, very valuable to us. I really appreciate it.
Well, mahalo for bringing us such an inspiring topic. And really the real bottom line is I'm really excited to eat local clams. I hope we can make this work. Thanks to everyone for contributing to such a rich discussion. And please contact Dave to continue to offer your support. I'm sure you will have other ideas once we go offline. We'll see you next month, and we'll send links to today's events as well as future events. But thanks everyone for joining. It was so great to see you all and to know that there's a little bit of an appetite for these kinds of conversations. So mahalo nui everyone, and take good care.
Thank you.
Bye.
Hey, Dave.
Thank you.
Oh, sorry, Shermaya. I think Dave dropped off.
Yeah,
do you have his email address?
I'll get it from Kai.
Okay, yeah, or we can send it to you for sure. It's just
All right.
Dave@KauaiSeaFarm.com.
Okay, thank you.
Mahalo.